Hello everyone. This is one more question in our series of JE Kinematics Numericals. And here the question is, there is a particle moving in a plane with this velocity having I component as well as j component along x and y axis. If initially particle is at origin, calculate the trajectory of the particle. Okay, they are asking us to calculate the trajectory equation, and obviously option B is supposed to be as the right answer. So procedure of calculating trajectory equation is, one must be available with the x coordinate and y coordinate of the projectile or particle as function of time. Okay, then from these two try to eliminate t. If you eliminate t, then you end up with the relation between y and x as y is equal to function of x. This y as function of x we call as trajectory equation. Okay, trajectory equation creation is with by following this method one can get easily. But here if you observe in the question, there is no x as function of time, y as function of time, but they have mentioned the velocities. So from that velocities one have to create the positions. So here very clearly what is Vx? Vx value is u0, which is constant, of course, along I cap. Can I write it as a dx by dt equal to u0? Hence dx is equal to u0 into dt, and integrating on both sides. As u0 is constant, we can take it outside directly in integration process. Initially it is at origin, so at t equal to 0, x is 0. At t it could be at x, so you will get x is equal to u0 into t. Okay, you are ready with x as function of time. Let it be as equation 1. Now similarly, let us see at Vy value. Vy value is a omega cos omega t. So Vy equal to a omega cos omega t, which implies dy by dt is equal to same function. One more time let me write. Hence dy value will be equal to a omega cos omega t into dt. If you integrate on both sides from 0 to y to 0 to t on both left and right side, now you will be getting y equal to a omega sin omega t by omega. We know integral cos x dx is sin x, but here it is like a cos kx dx, so you will get from chain rule divided by that constant. So here you got by omega. Okay, this is by omega you got here, omega got cancelled, so y equal to a sin omega t is what? One more equation we can highlight as the second equation. Now we are available with the x as function of time, y as function of time. So eliminating t is our next left procedure. So from here can I write t equal to x by u0? So let us try to substitute that in equation 2. Therefore y equal to a into sin of omega t as x by u0. X by u0. So the relation what I end up here is, there is a relation between y and x, which is like y equal to a into sin of omega x by u0. Okay, see, y equal to a into sin of omega x by u0. So as shown here, option B is correct here. Okay, hope so you understood that the clarity about the procedure, how one can get the trajectory equation of any particle moving in a given plane. Thank you.